Okay, imagine this for a second. Some huge object, way bigger than Jupiter, just drifting through space, not tied to any star. And the James Webb Space Telescope, our best eye in the sky, it actually studied it. That's what we're diving into today.
Yeah, it's pretty wild stuff.
Totally. It's all based on some great insights from Space Today TV, specifically Sergio Saccani talking about Webb's finds. So for everyone listening, think of this as your shortcut to understanding this really cool cosmic discovery.
Right, and our goal here is basically to unpack it. What is this thing? How did Webb even find it? And, why are astronomers so interested?
Exactly. Without getting lost in, super technical details, we want to get the gist of it.
Absolutely, because this discovery, this rogue planet, it's not just another speck out there. It's a genuine head-scratcher. It really makes you rethink how planets and, things like planets form. So, yeah, let's get into it.
Okay, so rogue planet. The name itself sounds pretty cool, like some kind of cosmic outlaw. What exactly is a rogue planet?
Well, think about our solar system, right? Earth, Jupiter, Mars, they all orbit the sun.
Right.
A rogue planet, sometimes people call them orphan planets. It's got the mass of a planet or thereabouts, but it's not orbiting a star, it's flying solo.
Just wandering through space all by itself.
Exactly, a solitary traveler in the dark.
And this particular wanderer, the one Webb looked at, what's the big deal about it?
Well, this one's been classified as a super Jupiter. Now, Jupiter's already huge, right? King of our planets.
Yeah, massive.
This rogue object is roughly 13 times the mass of Jupiter.
13 times. Wow.
Yeah, and just for context, astronomers usually put super Jupiters in the range of, say, 5 to maybe 15 times Jupiter's mass. So this one, its official name is SIMP J0136. It fits right in there, kind of on the high end, actually.
Okay, so 13 Jupiter masses, just floating free. That's hard to picture.
It really is. It definitely challenges how we think these massive objects come about.
And you mentioned it's relatively close by, too, something like 20 light years.
That's right. Which, in galactic terms, 20 light years is practically our backyard.
Okay.
And that closeness is great, obviously. It makes it a much better target for detailed study.
Right. So its size being that massive, it just begs the question, how does something like that end up alone? What are the theories about where it came from?
Yeah, that's the million light year question, isn't it? The source material, Space Today, mentioned two main ideas scientists are kicking around.
Okay, what are they?
The first is maybe it started forming like a star does, collapsing from a big cloud of gas and dust. But maybe it just didn't quite gather enough mass to kickstart nuclear fusion in its core, the process that makes stars shine.
So like a failed star.
Exactly. We call those brown dwarfs. They're kind of in between giant planets and small stars, usually around 15, maybe 80 times Jupiter's mass. This object at 13 Jupiter masses is just below that typical brown dwarf range. So maybe it's like an almost star that didn't quite make the cut.
Interesting. Cosmic lightweight, relatively speaking. What's the other main idea?
The second hypothesis is that it actually did form like a regular planet, orbiting a star in some system way back when.
Okay.
But then maybe because of gravity tugging from other big planets in that system, or maybe just the general chaos of a young solar system forming, it got violently kicked out, ejected.
Whoa! Kicked out of its own solar system.
Yeah, sent flying off into space on its own. The source also touched on a third possibility, though with less detail, that maybe these things can just form independently like planets do, but just without a star to orbit from the get-go.
So we've got failed star, ejected planet, or maybe independent formation. Sounds like we need more evidence.
That's the key takeaway, really. As Sergio Saccani pointed out, in astronomy, especially when you find something unusual like this, you really need more examples.
Right. You need a bigger sample size.
Exactly. More discoveries mean you can do proper statistics, build better models, and hopefully figure out which formation story, or maybe combination of stories, makes the most sense for these rogue objects. Each one we find is another piece of the puzzle.
Finding them sounds incredibly tricky, though. I mean, if it's not orbiting a star, it's not reflecting starlight, right? And it's not shining itself.
Correct.
So how did Webb even spot this thing? What's Webb's secret weapon here?
Well, that's where Webb's specific capabilities are just perfect. You're right, rogue planets don't give off much visible light, and there's no starlight nearby for them to reflect.
So they're dark.
Pretty much. Invisible light. But they still have leftover heat inside them from when they formed.
Oh, internal heat.
Exactly. And that internal heat radiates away as thermal radiation, which is basically infrared light. Think of like a hot engine cooling down. You can feel the heat radiating off it.
Yeah, yeah.
It's sort of like that, just much, much fainter in the infrared spectrum.
And infrared is Webb's thing, right?
Yeah.
That's its specialty.
Precisely. The James Webb Space Telescope is hands down the most powerful infrared observatory ever built. Its instruments are incredibly sensitive, and being out in space away from Earth's warm infrared blocking atmosphere means it can detect these really faint heat signatures from objects like SIMP J0136.
That's amazing. So it didn't just see it as a heat blob, it actually analyzed it. You mentioned something about its atmosphere. Can these things even have atmospheres?
Well, atmosphere is maybe a loose term, but yes. What's really incredible is that Webb used infrared spectroscopy on the heat coming from the object.
Spectroscopy, breaking down the light.
Exactly, like using a prism on sunlight to get a rainbow. But here, Webb is analyzing the infrared light, the heat radiation, to look for the chemical fingerprints of different molecules in the object's upper layers.
Okay, so what chemicals did it find? What's in the atmosphere of this super Jupiter?
The analysis showed clear signs of water vapor.
Water out there.
Yep, water vapor, also carbon monoxide and carbon dioxide.
Wow. CO and CO2 as well. What does finding those tell us?
It's huge. Detecting specific molecules like these gives us real clues about the object's composition. And that can tell us about its temperature, maybe hints about how and where it formed. Studying this atmospheric glow helps piece together its history and evolution. It's like a chemical snapshot.
A chemical snapshot of a starless world. Incredible. So Webb's opened the door here. What's next for studying these rogue planets? Are we going to find more?
Oh, absolutely. The future looks really promising. The source material highlighted the next generation of massive telescopes being built on Earth.
Like those giant ones in Chile?
Exactly. Things like the ELT, the Extremely Large Telescope, and the GMT, the Giant Magellan Telescope. Plus, there's the Vera C. Rubin Observatory, which is actually set to start its survey pretty soon, I think this year.
Bigger eyes on the sky.
Much bigger. These telescopes will have incredible power to gather light and sophisticated instruments perfect for hunting down more rogue planets, even fainter or more distant ones.
So the goal is just to build up that sample size we talked about.
That's a major part of it. Find more, study them, compare them, build up the statistics so we can really test those formation theories, failed star, ejected planet, something else entirely. Understand how these mysterious objects fit into the whole galactic picture.
Okay, one point of clarification Sergio Saccani made, which seems important. This thing, SIMP J0136, it's a rogue planet, not an exoplanet. Can you just quickly explain that difference again?
Yeah, definitely worth repeating. An exoplanet, by definition, is a planet that orbits a star other than our sun.
Right, exo meaning outside our solar system, but still orbiting a star.
Precisely. Since this object, SIMP J0136, isn't orbiting any star, it just can't be called an exoplanet. Simple as that. You might sometimes hear people say wandering planet, which is descriptive, but rogue planet is the more scientifically precise term for these starless worlds.
Got it. Rogue planet, not exoplanet. Okay, so let's try and wrap this up for everyone listening. We've been talking about this amazing find by the James Webb Space Telescope, a massive object, like 13 times Jupiter's mass, called a super Jupiter, just drifting alone about 20 light years away.
Which is pretty close, cosmically speaking.
Right. And because it doesn't orbit a star, we call it a rogue planet. And Webb, using its incredible infrared vision, could actually study the heat coming off it.
Allowing it to detect molecules like water vapor, carbon monoxide, and carbon dioxide in its, let's call it, upper layers or atmosphere.
Yeah, giving us these fascinating clues about how it might have formed maybe a failed star, maybe kicked out of another system. We still don't know for sure.
And the hunt is on, with new telescopes coming online soon to find more of these galactic nomads and really solve the mystery of their origins.
It really is just remarkable, isn't it, that we have the tech now to not just find, but start to actually analyze these incredibly faint, hidden objects out there in the dark.
It absolutely is. It opens up a whole new window onto the sheer diversity of objects that populate our galaxy, things we couldn't even really imagine studying just a couple of decades ago.
Totally. And it just makes you think, what else is lurking out there? In those huge dark voids between the stars, what other completely unexpected types of objects might be hiding beyond where we normally look? And what kind of, completely new telescopes or techniques are we going to need to invent to finally uncover those secrets? It feels like the universe always has more surprises up its sleeve.
That seems to be a recurring theme in astronomy, yes. Discoveries like this just remind us how much more there is still to find.